Is this on? Yeah. Hi, everyone. It's on. My name is Doron Zavelevsky, and I'm a principal engineer at Applitools. We're a company that provides a cloud service for automated visual testing. And today, I will talk about codeless visual testing. So what do I mean by codeless visual testing? By the way, counting the number of people here, I should have chosen a better title, I guess, because previous talk, it was a packed room. So I assume that many of you are familiar with or can assume or figure out what the codeless part is about. We'll address it first. Some of you may have an idea what the visual part means. I might be already overselling it. And at this point, I really hope that someone will ask me what testing means, but you're still shy. Jokes aside, this is the agenda. We will talk about codeless testing, tools, controversy, pros and cons. Then we'll understand what visual testing is, and then we will see the strength in the combination of the two. So codeless testing is made possible using record playback tools, such as Selenium IDE and Selenium Builder, just to name a couple of free open source solutions. And there are many more, including proprietary solutions such as UFT, LeanFT, TestIO, if you heard of them. And as you may well know, an automated test consists of two main parts, interaction and validation. These tools attempt to provide us with a way to achieve both without writing any code. So as a matter of fact, this is a good opportunity in front of this audience to share some news. After it became apparent that Selenium IDE, which is one of the most popular record playback tools, at least open source tools, will no longer be supported as of Firefox version 55, I was encouraged by my company, Applitools, to contribute to creating the next generation of Selenium IDE. So I'm glad to let you know that we joined forces with the awesome contributors of Selenium project in creating and developing the new web extension that will support Chrome, Firefox, and almost any other modern browser. It will have all the capabilities of the Selenium IDE that you know, and hopefully even more. A very early alpha, yay! Yeah. A very early alpha is already available for you to try out. I didn't manage to put it on the Chrome extension store in time, but it will be there, and you can test it and provide feedback. I will give you a quick demonstration of what it does, and remember, it's a very early alpha. Mirror displays. So I'll just open Chrome. So you can see the look and feel. This is beside the talk. A bit more modern than what you used to. It can already do a couple of stuff. Let's just go ahead and record some interactions. Hi, people. Oh, yeah, it's working. Nice. Let's close it. Yay. And run it. Yes. So it's a work in progress. It's not really impressive. But you are watching Selenium IDE on Chrome, not Firefox. I can do a couple of neat stuff, which is supposed to be obvious, but just play a single step, detect an element, stuff like this, really nice. So that's it for now with the Selenium IDE. And we'll go back to the presentation. Yep. Okay, Until it's ready, you can follow the project by simply watching it through GitHub, following the link here. Just copy-paste it from the screen. You can, of course, contribute by trying it out, reporting issues, creating a pull request, of course. Once completed, you should be able to use it to record tests, play them inside the browser and through Selenium WebDriver, export them to Selenium code in different languages, and use different plugins to extend its functionality. So back to my original talk. My work revolves around test automation. I'm using Selenium at Applitools to test the Applitools website and the Applitools web application that we develop in my team. And I also wrote different tools for Selenium WebDriver. But only recently, when I started contributing to the new Selenium IDE, I really started being part of the Selenium community. So I started lurking in the IRC channel and in the mailing group. And I noticed that there are very strong opinions when it comes to record playback tools. One opinion I heard more than once, more or less, was testers should write code. Record playback tools are bad because they encourage the exact opposite. I think this opinion is mostly the result of the gap between theory and practice. In theory, record playback tools are an excellent thing. They have the obvious advantage of providing a quick and easy way to create test coverage while abstracting all the details, implementation details, away from the users. The reality is that sooner or later this abstraction breaks. And the point I want to make in this talk is that this gap is becoming narrower and narrower, and you should keep an open mind. The other opinion is, yeah, whatever, when will Selenium IDE be supported again? Now, the way I see it, my personal opinion is that the test automation developer experts can benefit a lot from building their tests using code. And it's the most, in my opinion, it's the best and most rewarding option. In fact, this is what we do at Applitools. But code is still a tool. It's not the only tool, and it might not be the natural choice for everyone. For these cases, I'm glad to see the ever-improving record playback tools that provide an alternative, and we'll see that it's a viable alternative. In some aspect, it's even have some benefits over code-based tests. So the facts are that record playback tools are very popular. IDE has, last time I checked, over 100,000 users according to Mozilla. Selenium Builder is in the thousands, and there are many other tools. There's an entire plethora of commercial tools too. Some of them bring a lot of innovation to the game. What do we learn from that? One, that there's a high demand for record playback tool, for codeless automation, sorry. And it's safe to say that people work with them successfully. They manage to do the work and without, while avoiding using code. So how come? So let's ask ourselves, what is the skill set that's required of test automation developers? Now, at this point, I wanted to address you and ask you to suggest skills that are required for test automation developers, but then I realized that this is not really a chalkboard, and I can't write your suggestions, so I made a list myself. Just a slide looking like one, really confusing. So let's go over the list one by one. Understanding how browsers work. So it is necessary to understand how the browser works, what are the different flows and events, the application lifecycle that takes place once you navigate into a page, things that you have to wait for before doing specific actions. Then you have understanding how the application and the test behave. You have to understand your application, you have to understand different conditions, how to trigger and reach interesting states in the application. Now, you have to have a logical thinking in order to understand the conditions that require to create valuable tests, problem-solving skills, accuracy, and attention to details. And there are the last four, understanding selectors. You got to pick the right ones and not depend on passes, on hierarchies that are prone to break. Ability to design for maintainability. You want to design your tests so they will not break easily when the application changes. It will be easy to adapt, easy to extend, easy to reuse. You need to understand what is control flow, conditions, loops, so you can create complex logics of interaction and validation. And you want to know the syntax of a programming language. What I claim is that almost all of these skills are required also for succeeding in using record playback tools. I think that you will agree with me about the first ones. Of course, the last one isn't relevant, so let's examine the last four. Let's go one by one. Understanding how selectors work. You need a skill no matter what. Either because the tool might produce suboptimal selectors, or because breaking the changes will require the users to fix the selectors sooner or later. This is one of the claims against using record playback tools, that they produce selectors that are based on passes and hierarchies and they're prone to break. I agree with this, but I think it's a matter of personal responsibility. Also, it's worth mentioning that there's a lot of innovation in record playback tools lately. I'm seeing new startups creating really interesting tools that use machine learning and smart algorithms in order to collect as much information as possible of each element that the test interacts with. So they create selectors which are even smarter than the ones that you use when writing code. Well, there's Oren Rubin from Testing.io, exactly. His product does a really great job doing this. So it allows a lot of time for being able to recover from tests that broke, some selectors that weren't really accurate or no longer accurate. Design for maintainability. How would a developer achieve this? He will use good practices of software engineering, create abstractions, separation of concerns. He will keep things loosely coupled. But in many of the record playback tools, you get a lot of this out of the box, because many tools provide you with abstractions, such as object repositories or stores, test objects, abstractions around different functions that you want to create and different interaction. So you get all this software engineering out of the box. About control flow. Developers understand control flow, they understand conditions, if, else, loops. It allows a lot of power. It allows to achieve complex interaction logic, complex validation logic, and nonlinear test flow. You can add loops to your test. You can repeat different tasks. Now, some tools allow advanced editing of the recorded steps. So a tester doesn't necessarily have to simulate a loop by repeating the same test over and over again. But yeah, no doubt about it, when there's a lot of advantage to using code when it comes to a smart control flow. And well, programming language, of course, is the one skill that really separates developers from users of record playback tools. But let's see what we're missing by not using code and how we can diminish the negative impacts. Now, what are the cons of using record playback? Dependency in tool, not much getting around it. You're almost limited to linear test flow. It's hard to do highly conditional interaction, and you cannot record complex validation logic. So to conclude part one, programmatic approach gives more flexibility and freedom. Record playback cons, as we just say, recording complex condition, tool dependency, and it's linear. And the pros, it's quick and simple way to write tests, at least in theory. It allows you to use next generation selector creators. And it's an alternative for when a programming language is a barrier, which is the case with a lot of people. So let's put this aside and move on to part two, where I speak about visual testing. Visual testing aims to validate the UI appears correctly to the user. For those of you who are not familiar with this type of testing, it goes beyond the traditional functional testing that you are used to using Selenium, Appium, and record playback tools, where you test the functionality of the application through the UI. What visual testing is focused on is making sure that the UI itself is rendered correctly and displayed correctly to the user. Each element appears in the right position, shape, size, color. It doesn't hide any other element. It doesn't overlap with other element. Let's see a few examples. Here you can see an example from the Twitter application where, due to an arrow screen, you can see the text of the first message overrides the message below it. Now, this is exactly what visual testing tools can easily find for you. In this page of the Financial Times website, you can see the main title. Also, it went down one line. Now, think of how challenging it would be to detect such a bug using validation code. Sorry. This is how the Amazon website looked for a couple of hours during one of them, their Amazon Prime Day sales. This is a fully functional website. I think that a functional test would pass when testing this website. But visual validation shows that this is not the desired look of the website. So how does it work? It's quite simple. It's a visual testing tool. The workflow is simple, and it uses 3 separate steps. You start by driving the application under test and send the screenshots. In ApplyTools, we have many SDKs and plugins to common automation tools to make this job easier for you or completely do it instead of you. Then we compare the images to the new images that arrived from the test to baseline images. Now, baseline images represent the application in each point of the test, the expected state of the application. It's actually images that you sent in previous runs and approved them as correct. Now the tool will generate a report containing the baseline images, the new images that arrived, and the differences between them. And this is the point where you analyze and you go over the different steps, and you see if there are differences. If there are not desired differences, then you open a bug. And if it's a valid change, you accept the new screenshot, and they will be used as baseline images for the next runs. Now, take a look at this code. It provides a very nice coverage of the welcome pages of GitHub. I want you to notice how short it is and quite simple. Because it uses visual validation, there's no validation code, only calling check window to make the visual validation. And we also need a very basic interaction code here. We only navigate through the pages and take screenshots. And it provides us with nice coverage really quickly. So to conclude this part, automated visual testing is a powerful validation tool for the state of the UI. It leads you to write less code, both for interaction and for validation. And this is an important point. It finds bugs you weren't even looking for. This is one of the things I like about visual testing, because when you do functional testing, you try to reproduce a certain bug that you are aware of, and you test specifically for it. But things around it can be broken, and you wouldn't notice. Here you take a full page screenshot, and there's room for surprise. You can find out about a bug that you weren't even expecting. Now we reach part 3, where you look at what we get out of combining the two, codeless testing and visual testing. Let's recall what were the weak points of record playback tools. So now that we add the visual validation, we see that we need much more simpler interaction and simple validation, because the visual validation replaces it. And also I can strike through the selectors, because it diminishes the problem of the complicated selectors, because we need less of them. We do simpler interaction logic and simpler validation logic. By the way, even saw instances where the validation of the UI specifically was better when you did it in the visual way and not using code. Now, the fact that the control flow is linear is also less of a problem, because mostly you use conditions and loops in order to do very complicated validation. But here, as I said, it was replaced. And I'm leaving tool dependency here, although it is also less of a problem because now that your usage of the tool is much simpler, it is easy to migrate out of it if necessary, and higher chances that the code that you export from your tool, say to Selenium code, will work because it's a much simpler code. Okay, what I want to do now is to use a Selenium builder and use the Applitools plugin to quickly create a codeless visual test for GitHub. And I want to see how quick and easy it is. I will happily demonstrate using the new Selenium IDE, but it's still not there yet. So just a sec. I will launch Firefox. I'll go to the GitHub page of the new Selenium IDE project. I will launch the Selenium builder and start recording. I already installed the Applitools plugin. I just call it IDE GitHub, call the test demo. I want it to be the inner viewport to be a bit higher. And then I like to begin with the initial state. I just take a screenshot of the initial window, of the initial display. Then I'll go to sign up page of GitHub. I take a screenshot here too. And then I go to the sign in page. I take a screenshot here. All I have left okay. All I want to do now is just give it more interesting names. So I'll call it I will give it more informative names. Okay, that's it. I'll stop the recording and I'll run it using Selenium server on Chrome this time. Now it takes a full page screenshot by taking screenshots of the viewport, scrolling through them and stitching them together, sending them over. And here in a few seconds we created a really nice validation of GitHub. Now that it's done, I can open Applitools management console and see the test results. And see that indeed many things have changed. Yeah. Mostly because I think that someone made a few commits. So it's up to me to decide if these changes are what I expect, and I can approve them, I can reject them. I can go in and decide that it doesn't make sense to test the part of the dates which is quite dynamic and simply ignore it because it's too volatile. But this is a combined record playback tool with visual validation to achieve a really nice coverage in a few seconds, while diminishing a lot of the shortcomings of record playback tools. I'll go back to the presentation, which nears the end. How much time do I have? Okay. Seem to be on time. Okay. So just a few takeaways. Using code for test automation is always the right choice. You're not mistaken to do it. Record playback tools become smarter and more innovative each year. Visual testing supercharges your tests, and codeless visual testing diminishes the impact of not using code. And also, Selenium IDE is coming back. Please spread the word, because many people were informed that it's reached its end of life. That's it. If you have any questions or just want to stay in touch, you can ask now or approach me later. Thank you very much.